Good morning, everyone, and welcome to Chilling with Naomi's. My name is Jordan, of course. Sorry I didn't post a video in the last few days. I promised to do one or two every weekend. I got sick, it happens. But anyway, today's video is going to be on Tesla coils and transformers. Because Tesla coils and transformers are essentially the same thing. Tesla coil is just a air core resonant step-up transformer. So, a very fancy one that can produce high voltage. So what is a transformer? Well, a transformer is an electrical device that we use to either increase or decrease voltage. So you step up voltage and you have to step down current proportionally, because you can't break the first law of thermodynamics, that the universe, you can't create more energy out from nothing. There's no such thing as free energy. So you step voltage up, you have to step current down the exact same proportions. Same thing, if you step voltage down, you can step your maximum current up, also with the same power. So it transforms voltage and current, not power. Power is the same throughout. So what is a transformer? Well, let's get black here. Transformer is this. This is a very crude design of what you would see on a schematic for a transformer. What it is a coil wire here and a coil wire here. Inside it can be air, it can be a ferrite metal such as iron or steel, which increases the coupling and the overall efficiency of the transformer. So transformers, you put, say, 1 volt in here, 1 volt, and you want 10 volts out here, you would do 1 turn here and 10 turns here, and this 1 volt, multiply it by the ratio, becomes 10 volts. Now you wouldn't just want to do the 1 turn around your core of your inductor. The reason why is that's way too much current draw. You have very little impedance, very little reactance, very little resistance to the current going through. That's my cat scratching at the door. Let him in. Anyway, this going here with only 1 turn, you would think every transformer, you can just have 1 turn and then as many turns on the secondary as you want to get your voltage. Well, the overcurrent of just 1 turn is too much. So you put as many turns as you need on the primary in order not to get enough reactance, not to overcurrent the transformer, and then build your secondary how you want it. So a Tesla coil is a little bit different in how transformers work. So in most transformers, you are using a non-resonant circuit. And remember, resonance comes from this: a capacitor and an inductor, either in series or parallel. Capacitors hold charge in an electric field, inductors in a magnetic field. When the capacitor gets full, it discharges into the inductor. When the inductor gets full, it discharges the capacitor. Theoretically, if there's no power loss, that would happen for eternity, even after you remove the power supply. But it doesn't, because there are imperfections that give power loss. But you're saying, well, if I want really high voltage, I just make 1 or 2 turns of wire, and I just make as many secondary turns as I can, hundreds, thousands, whatever, to achieve my output to be extremely high voltage. Well, you can do that. The problem is it's very hard to get coupling, and that coupling is how well the primary inductor, the one you're feeding power to, and the secondary inductor work together. So the power efficiency between the two is called your coupling. And when you only have a couple of turns on a primary and tons of turns on a secondary, you can lose that coupling, and it's not going to be as efficient. But still, you could theoretically put, say, 10 turns of wire to help limit the current, and 1,000,000 turns on the outside, and get 100,000 volts out. Yes, that will work. 1,000,000 turns, though, is going to be a lot of work. It's very hard to do, and yes, you would have to physically count every single one of those 1,000,000 turns. but theoretically it is possible. It is done in some research environments. But a Tesla coil, or an air core resonant transformer, is a way to cheat the system. So let me wipe that away. And that is putting the transformer into resonance. So how do we do that? So we have here from power from the wall goes in to a transformer here. So let's say 120 volts. And for my setup, I have five 30 milliamp, 15,000 volt neon sign transformers to power Tony, the Tesla coil. Well, I have them wired in parallel. So when you wire stuff in parallel, you add the maximum current output. You don't add in voltage. If you put power supplies in series, you add in voltage. You don't add in current, maximum current. So a Tesla coil, we have this 120 coil, 120 from the wall, and then we have many more turns to get to our 15,000 volts. And that is done at 60 hertz if you're in the United States. I believe Canada is still using 50 hertz, but 60 hertz here in the US. So the trick is not just to up the turns ratio, but to also up the coupling and what's called resonance rise in a resonance frequency transformer. So to do that, we simply add, actually, I'm going to draw how mine is. There's two ways to draw a Tesla coil schematic. And I'm going to draw mine exactly how mine is. So here, excuse my autism as well, but also excuse my artism, or however you say it, I don't know. Anyway, there's your capacitor. Here is a spark gap. I'll explain what that does later. Here we have a few turns of a second primary inductor. And what does this circuit do? Well, what happens is when the voltage across this capacitor, because originally when you put voltage on a capacitor, the capacitor pulls it all in. It pulls it all in and absorbs it. But once the capacitor's energy rises high enough and the voltage rises high enough, we'll get a jump of electricity across this gap. And when we get that jump of current, it's going to go through this inductor. And then when the capacitor charges negatively the other way, it will charge and charge and charge, and once it's high enough high enough voltage across the spark gap, it will jump back this way. So you'll get your AC from here and turn it into AC here, but you're turning it into AC not based on primary and secondary turns here, but you're turning it in, resonance, primary and secondary here, but now you're turning it to the resonance of this capacitor called the tank capacitor and this inductor called the primary inductor. So now you've changed the 60 hertz into whatever your frequency of your tank capacitor and your primary inductor are. And for me, my Tesla coil works out to be 202,000, so 202 kilohertz. So 202,000 cycles per second. That's really fast, but you have to get it exact. And why do I say that? Why do the value of these parts matter? Because we need to get these to resonate with something else. And what we're getting those to resonate with is this. This is the big tower. Big tower in the middle of a Tesla coil. It's called the secondary coil. Now on here, for my design, I have 7 turns of copper tubing. And on the secondary side, I have about 1,200 turns. Yes, I wound it by hand. Yes, it took 10 hours. Yes, it was worth it. Of 1,200 turns of wire. So not only am I getting the rise in voltage from the 7 to the 1,200 ratio, but as long as this capacitor and this inductor stay at relatively the same resonant frequency as this inductor and the top of the Tesla coil this guy, this capacitor. So this capacitor is a plate suspended above dielectric, air, and earth is the other side of that plate. So it acts just like a capacitor and inductor in a circuit, so it has a resonance. Best way to find a resonance of a secondary circuit is to use a signal generator oscilloscope combo, sweep the tune the frequency of the output of your signal generator across from your ground to the top load, across there. Tune your signal generator until you hit a frequency where your voltage on your oscilloscope jumps, spikes. That is your resonant frequency. And then you match that frequency to this guy and this guy. And the cat's moving the... But anyway, you match your resonance frequency from one side to the other. One primary from your capacitor inductor here to your secondary capacitor inductor here. And you might be thinking, okay, what is resonance frequency? Why does it matter what frequency things are oscillating at in my circuit? Well, think of it this way. What if you're pushing a kid on a swing? Okay, you're just pushing him away, and you're just throwing as much energy randomly in there and just every which way. What will happen? He's not going to move very far. But if you push them on the swing at the right time with the right amount of force, over and over on that same frequency of pushes, that same time of pushes, he will go really, really high up on the swing. Same thing is true with a Tesla coil. Exact same thing is true. So that is the premise of a Tesla coil. That's how a Tesla coil was originally designed, of course, by Nikola Tesla, and how they work. And that's a little bit about how transformers work and what they do as well. Of course, you can also go the other way and step down voltage incredibly low and your current way up and melt things. But for today's video, we're talking about getting as high voltage as possible. And I've did some experimenting, and I think my voltage off the Tesla coil, well, you can't really measure it with anything because it's so high, but judging by the distance it jumps through the air, suffice to say, it's between 300 and 400,000 volts AC. So, every time this guy has a jump across this gap, remember, that's going to put a pulse on this transformer. You're going to get a pulse of electricity going up to the capacitor. It's going to jump off the capacitor in the form of a streamer, and then the energy is going to go negative. It's going to go down, and once it gets to the bottom, you want that next pulse to hit right then. So that's more about resonance frequency. I'm going to go ahead and show you some video of my Tesla coil. It's a rotary spark gap Tesla coil. So I have a motor here. And the reason you do that is to extinguish the spark, because if the spark hangs around too long, that's low resistance across your spark gap, and you're going to mess with your frequency. Interrupting the spark gap is very key in maintaining efficiency. So I'll go show you my build here in a minute. Thank you guys for watching the info and lecture part of this, and now we'll go to the show and tell. Thank you. Alright, good morning everyone again. Here we are out in the garage, and I'm going to show you here Tony the Tesla coil. Walk you through them. So back here, in the back, we have 1, 2, 3, 4, and 5 neon sign transformers, all 15,000 volts, 30 milliamps each, give me a whopping 15,000 volts at 150 milliamps in total with them in parallel. Right here is the rotary spark gap. So this goes ahead and turns. This is some 3D printed plastic on a motor, and then we got bolts with acorn nuts or cap nuts to make the strikes, make the arcs from strike to strike. And right there we got some sheet of aluminum to act as a conductor, and some nuts to act as locking for this mechanism. But you can see how it will spin, arcs will make and break, and it will keep extinguishing the arcs so current doesn't keep flowing when I don't want it to. And this all happens, of course, at extremely, extremely high speeds, so it's impossible to see the individual arcs or current or anything. It's just all one big mess of light and noise. And then over here I have the safety gap safety gap is used if the voltage gets too high across my rotary spark gap. The safety gap will just extinguish that to protect my transformers. And then over here we have, in this tube I made, we have two high voltage, high frequency capacitors. These are impossible to get. Somehow I found them one day on eBay. And they are rated at 20,000 volts each, so 40,000 volts in series. And they're rated at 50 nanofarad, so 25 nanofarad in series, which is perfect because my math works out that I need about 26 nanofarad in order for it to match resonance with the secondary, and that's close enough. So I take around here my messing garage. This is the primary coil. This is what the 15,000 volts goes across. This is what gets driven by actual power, and then gets transferred over to this guy, the secondary. Yes, if you can see the individual wires right there, I wound that by hand. It took me 10 hours. I was watching Futurama while doing it. Totally worth it. And there we have the top load that acts as a secondary capacitor. Really small for this build. I'm going to make a bigger one, but this is what I could find at the moment. Over here we have the strike rail going around. Strike rail is so if arc from Tony's output here doesn't go into my 15,000 volt drive, it goes into the strike rail. Let me get a wider view of him. You can see some of my other projects there in the corner. There's Tony. Not only does this kill you, it'll hurt the whole time you're dying, and that is true, believe me. And then here we have the output, and we have a grounded secondary made out of IKEA salad bowls there. Goes to the output here, and we can make some big arcs. So let's do that. Let's make some big arcs. I'll see you in a minute. Other thing I want to show you, I'm again using a auto transformer, otherwise known as a variac, because giving a coil full 120 volts all at once, that's asking for trouble. So we ease her up gently for that. Alright guys, here's take two. It occurs to me that my cap nuts on my spark gap side are very burnt down. Those do occasionally require replacement, and today it seems that they really do after I've been running it. So gotta get those from the store. Hopefully this adjustment is good enough for now, but until then we'll go ahead and get another shot. So here comes the rotary spark gap line. Let's crank up Tony.